So, binomial expansion. Is there anything you wanted to ask about the binomial expansion that we did yesterday? No? So you remember we did it long way, we then looked at when we expand, well I deleted it, didn't we? But we ended up with Pascal's triangle to give the coefficients. So the rest of it was relatively straightforward, wasn't it? So if I were to refill in this line for a plus b to the power of 5, the first one would go with a
0. Oh, b, a 5.
a to the power of 5, and then we would plus 5
b, a4, b1.
Okay, plus 10
a3, b2.
plus
a2, b1.
B3.
Oh, b3.
plus
A1. B4.
plus 1
B5.
b to the power of 5. So we had the pattern in the A's and B's, and then we have the coefficients, and the coefficients came from Pascal's triangle. But we did move on from Pascal's triangle to start looking at this notation and how we can use that notation to find the value. So we looked at the formula, n factorial, okay, how we use that using the 8 and 3, for instance. How do we find that value? So n is 8, r is 3, and we did it all. No calculators needed, and we got the answer 56. So 56 is the coefficient of a certain term in an expansion. Which term would that be? What expansion would it be first? So if I was doing a plus b, it would be to the power of 8. You can see it down there, okay? Alright, so we know it's 8 because
The top number is 8.
the top number's the 8, so there's the n value. And then this number, how do we use that?
That's the number of
That's a
combinations.
Okay, so when we do our expansion, we are what? So for instance, if I didn't want to have to do, this is what we're going to look at today, by the way. If I didn't want to do the entire expansion, I could find just individual terms. So I know that it's 8, 3 is 56, so I'm going to have 56 lots of what with A's and B's?
A5, b3.
So A5, B. Okay. Is everyone happy?
Fine.
Okay, how do we get the 5?
Because the A and the B have to add together.
A and B
So
have to have, yeah. And how do I know the B is 3 then?
Because the bottom number is 3.
Because the bottom number is 3. Okay.
Okay.
Alright. Now there is another term which would also be 56. But it'd be A to the power of what and B to the power of what?
A to the power of
A3,
3.
B5.
Exactly. Because of that symmetry. Does that make sense to everyone? Yeah.
Because 8 over 3 and 3 over 8 are the same, right?
No.
8 over 3 and not 3 over 8, 8 over
Oh.
8 over 5. So 8-3 or 8-5 give you the same either way. Okay? Is that...
Wait, it doesn't matter.
No, it doesn't matter which one because they give you the same value. And you'll see that in your book. So if you wouldn't mind, let's turn to page 186 in your textbook. Right. And we'll just discuss this, the notation. So we've got a plus b to the power of n, and the expansion can be written as n0, and then we would write a to the power of n minus 1 times b to the power of 0 in this case, because it's the first one, yeah? Plus, does that make sense? Actually, I'm wrong, sorry.
What are we looking at?
I'm looking, it should be a to the power of n, b to the power of 0. So the bottom of page 186.
Okay, like the red boxes?
Yeah.
Okay.
So I've got the first term will be n0. Now you remember what n0 will be as a...
1.
So it'll be 1. The coefficient will be 1. N0. So the next term will be n1, and then it will be a to the power of n minus 1 times b to the power of 1. The next term will be n over 2, and it will be n minus 2 and b to the power of 2. And we carry on. Does that make sense? You see what we're doing here? So if I wanted to apply a plus b to the power of 9, for instance, what I would have written up here, it would end up being, so 9 over 0, a to the power of 9, b to the power of 0 is always 1, so we don't bother, plus 9, 1, and it would be a to the power of, and I'm going to write 9 minus 1, which you know is 8, just to check, because this, I've had this thing in my throat. This might come in useful when we problem solve, just to think of it this way. So it'd be b to the power of 1, and then it'd be plus 9 over 2, a to the power of 9 minus 2, b to the power of 2, and so on. Okay, and we would be able to go all the way up to 9 over 8, a to the power of 9 minus 8, and then it would be b to the power of 8 plus 9 over 9, which would be a to the power of 9 minus 9, being 0, b to the power of 9. So you can see how that notation works.
Wait, where are we getting the 0 from? Oh, wait, never mind. Wait. That's because...
Should I put a b to the power of 0? Which one? So what we're noticing is that if that's 0, that's 0. If b is 1, that's 1. If b is 2, that's 2. 8, 8, 9, 9. Okay? And the top 9 comes from there. So that's why that one's there. Right? And then that kind of works there, doesn't it? So 9, that's what we use there. Now, you may well say, but hang on, if 9, 1 is the same as 9, 8, well, I could use either one. So either I use the b to give me the bottom number, or I use the a to give me the bottom number. It doesn't actually matter, okay? You'll see what I mean by that in a bit, okay? You alright with that? Do you want to write that down? Do you want me to stop? Or not? Or are you happy for me to move on? It's in your textbook anyway, isn't it? So I'm videoing it. I can send you on the Firefly. Right. There's probably no need to write it down if it's in your textbook. So what we should then do is think about it in terms of R's, because this will definitely help you with your problem solving. And Courtney's favourite thing, sigma notation at the bottom of the page. Okay, so we've got a plus b to the power of n. We're looking at adding up, so it's the sum of. Okay, we say n, and we have the r. Why r?
Is it R the ratio?
Not the ratio in this case, no. What's in the brackets?
Oh, n?
C, n, c, r, or it's n over r, isn't it? So that's why we have an r. So r being 0, so that's the sum of, and we say it's nr and then we would do is a to the power of n minus r times b to the power of r. Now, does that make sense to you? The sum of, because we add them all up, yeah? We do that expansion, we're adding
Okay, so
them all
the sigma is just a way of saying, like, this is when you're doing the sum.
Yeah.
Okay.
So when we do an expansion, we end up with lots of terms added together, don't we? So this is why we've included it in the kind of sequences and series topic, so you know about the sigma notation. So we can write our expansion like that if we wanted to. But it's about using the r value, the n and the r. All right. So you're going to have to sort of apply problem solving. This topic, the binomial expansion, is about problem solving. So most of the questions that you're likely to come across will be about solving an algebraic problem. So it's worth kind of just getting your head around that whole n minus r and r bit. Okay. Because we're still at a kind of simple case at the moment. Okay.
What a question.
Well, I tell you, should we go through a couple?
Yeah.
We'll go through the examples in the textbook now. That might make it more
Because
more
like, how
sense
would
to
you
you.
know what R was? If
Yeah,
you
exactly.
Didn't write it n over R.
Yeah, exactly.
Looks like a bunch.
Should we have a look? It says use the binomial. So, example 25 on page 187. I'll go through the examples with you. So it says use the binomial theorem to expand x plus 3 to the power of 5. Okay? Write your answer in its simplest form. So we've now not got the a's and b's, but we know that's what's going to happen. So this is like a plus b to the power of 5. So we can kind of apply the same thing. So we're going to write the expansion. So what do we have? Well, we've got n over r. Okay, well in this case, n is 5. So n is going to be the 5. Alright? So when we do our expansion, we're going to start with 5, 0 is the first coefficient. And the first term will be what? X.
N.
Well, we've got a
x5.
x to the power of 5, yeah. Well, if you think about it, if it was a plus b, if I tell you about a plus b to the power of 5, remember it was a to the power of 5 plus a to the power of 4b plus a to the power of 3b squared and so on. Now all we're doing is replacing the a's and b's with x's and 3's. So the first term is 5, 0, x to the power of 5, and 3, if I were to write it out, 3 to the power of 0. Okay? Plus, well, what's the next term? 5, 1, but it's x to the power of 4 times 3 to the power of 1 plus 5, 2, you tell me,
3.
x to the power of 3 times 3, 2 plus
5, 3, 3. X 2, 3, 3.
carry on down here, plus 5,
4, X, Y, 3, 2, 3,
plus
5, 5, 3, 5.
okay.
Would you have to write out every single?
Well, oh sorry, in this case they're asking you for the entire expansion, so yes, we kind of have to do it, but as you'll see in the textbook it says most of the time you don't have to do an entire expansion. Yet. Not yet.
Not yet. Are you kidding me?
So let's simplify this now. We've got to sort it all out. So shall we do the terms bit first? So we've got 3 to the power of 0 is just 1. So I'm going to rewrite it. Up to you if you do it like this. So it's 1 times x to the power of 5. The next term is 5, 1, and it's 3x to the power of 4. Then we've got plus 5, 2.
6x to
Careful.
9.
9x to the power of 3. Plus 5, 3.
27.
X squared.
Okay, I'm hitting
Times it by 3. Come on. It's 9 times 9.
81.
81. So it's 81x and then plus 5, 5.
243.
Sure?
No.
Why? Of course it's 243, isn't it? 3 times 8, t, 240, 3 times 1, 6. So, right, so what we've got so far, and this is an important part to notice, actually. The coefficients 5, 0, 5, 1, 5, 2, 5, 3, we haven't worked them out yet. Some of them, however, are going to have a coefficient and another number, so the coefficient is going to end up changing, isn't it? So, for instance, we know that this one is 1, yeah? So we're going to have our first term of x to the power of 5 plus, well, the coefficient is currently 5, 1, but what is 5, 1 again?
5, 1.
Do you remember the second number is basically the expansion, yeah? So it's a 5. So that's 5. But we're going to have 5 times the 3. So our coefficient is actually 15 x to the power of 4. Now because we have a number in our brackets before we expand, the coefficients are going to change. Now that's very important to remember, because what we'll end up having to do, we'll be asked to find the term where the coefficient is a number. And it's not quite as simple as just saying, oh, the thing in the brackets is that number, because we may well have something like this where we have a number and we have the coefficient together. Does that make sense? So we do have to take into consideration. Plus, well, now we might need to work them out. So if we've got a situation like this, remember how to use your calculators for it? You've all brought your calculators?
Yep.
Yeah? You all know how to do the NCR thing for these coefficients? So what's 5, 2?
How many kids do you want? 10.
10? Do you all agree? Do you remember how to do it? Yeah? Math, probability,
And C.
and
So
so,
do you
yeah.
then need to multiply that by the 9?
Okay, so we reckon that's 10. So 9 times 10 gives me 90 x cubed. Now, do I need my calculator for the next one?
Yeah.
Really? 5, 5 is
Oh, not
1.
that one.
This one is 5. So this one has to be
10.
10.
One.
So I don't need to do it. So then I get plus 270 x squared plus, well, 5 times 81.
Oh,
405.
405, good, x, plus 243.
That is a lot of work.
And that's it. That's in simplest form because we've got nothing else to collect. Now, like I said, you'll be pleased to know you don't very often have to do an entire expansion like this. But that's what makes it harder because you have to find one particular term. Now, I just want to tell you about a piece of vocabulary you need to be aware of. This thing here will become important to you. This is called a constant term. Any ideas why you think it's called a constant term and why the others are not a constant term?
Because it doesn't have any other variables, with no x's or...
Exactly, it doesn't have a variable. So the others, their values will change depending on what value I put in for x. Yeah. So I would say this is the term in x to the power of 4. So if I was asked, find the term with x to the power of 4, that's what I would be looking for, that particular term. Quite often a question is, find the constant term. Now the constant term doesn't always have to be that last one, although you might think it is. It's not always that last one, but we'll come up to that point. Okay? How do you feel about that?
How did you get the 10 for the 27x squared one?
Oh, because of the symmetry. So 1's either end, 5's either end, 10's in the middle.
How did you get
We worked that out. So this has to be the same. That's also a 10, yeah?
the... Okay, but how did you work that one?
So this one we worked out on our calculator. That was on your GDC. These ones we just know that's a 1, and this one is the first one is the same as the power for the expansion. I know the either ends because of the symmetry. So actually I only need, in this case, I only needed to work out 1 and I knew all the others. It's not always going to be that way, but so I just had to work out and then look at the symmetry. Look at the symmetry. And it's Pascal's triangle, yeah? Pascal's triangle. So obviously 1's at either end, then the 5's, then the 10's, and we're done. Does that make sense? Right, I could go through example 26 with you, but they've just added another number in. They've got x and y's and there's a subtraction in between. Do you want to just have a read through that yourself rather than me go through it slowly like this, and let me know if there's something you want to talk about?
Would they use the same?
Not very often, to be honest. It's just a way of putting it in your formula booklet. Now, yeah, I'll say what I was going to say later on. So you happy going through example 26 yourself, just for a couple of minutes? Apply what we've just done, see what they're doing. Okay, so let's have a look at example 27. Because on the whole, most of the questions that you're going to be asked to do will involve this kind of thing. Probably more complicated than this one, but it's where it starts. So we've got 4x minus 1, and it's being expanded to the power of 9. Okay. Now, we are not going to do the entire expansion. We want to find the term which has an x cubed. Right? Okay. So, as they get harder, you'll have to think about it a bit more, but what you know is when we do the expansion, this is the a and this is the plus b. Alright, so you're going to have the first expansion would be 4x to the power of 9, and it would be 9 over 0. That would be the first term. Now that would be x to the power of 9. So we're not interested in that one. So we're going to go all the way until we get 4x, but it's going to be to the power of 3, because that will give me the x cubed I need. Now we need to know, well, what's the thing going to be multiplied by? So it's going to be minus 1 to the power of 6. That's the whole they have to add up to 9 thing. And then in here will be 9 over 6. Or 9 over... What's the same as 9 over 6? 9 over 3. Yeah? So 9, 6 or 9, 3, either one, doesn't matter, going to give you the same. But what we now know is we've got that sorted. Right? So that's the term we need to simplify. Make sense? We just need to do it now. So what is 9, 6, the value for 9, 6? Calculate one. 84. Okay. So we've got 84 times, and then we're going to have x cubed, but we're going to have 4 cubed as well. So this will be 4 cubed x cubed. So that's why it said at the end of that blue box, don't forget to do that. So what's 4 cubed? Should be able to do that one. 64. Then we've got times x cubed, and then what's minus 1 to the power of 6?
1.
Just 1. Okay. So then our term will just be x cubed, but we've got 84 times 64, big number. We're going to get used to these big numbers. So 84 times 64 is 5,376. Yeah, it says in the book.
X cubed.
And it'd be x cubed. So that's the term with x cubed in it. Right? And the coefficient is not just the 9, 6. Do you see? If I asked you for only the coefficient of the x cubed term, you might say, oh, well, that's 9, 6, therefore it's 84. But it's not. It's 84 times the 4 cubed has an impact. Okay? Alright. Now, does that make sense? So I just want to ask you a question. Well, we can do another one. I just want to ask you a question to see whether you understand that. My question is, I'm going back up to exercise 6n, alright? And I'm looking at question 8, and it is the 4x squared plus 1 over 2y, and it's all to the power of 3. Okay. Now, it's asking you to do the whole expansion. But if I said to you, I only want one particular term, right? I want the term which has x to the power of, right, what possible ones are there that I could ask you for? So for instance, could I ask you for x to the power of 1?
Yeah.
Could I ask you for x to the power of 2, x to the power of 3, x to the power of 4? What's the maximum? X to the power of 5, x to the power of 6? Which ones could I ask and which ones can I not ask because they don't exist?
Past x to the power of 6. Yeah, that's the power of 6.
Okay, so I could do the x to the power of 2 to the power of 3 would be x to the power of 6, yeah? So that one I could ask you for. Any others?
Yeah, x to the power of 2.
X to the power of 2?
Yeah.
Yeah?
X to the power of 4.
And x to the power of 4. They're the only ones that I could ask you for, yeah?
If you could go higher than 6.
Oh no, sorry. Now I wanted to know which ones could I possibly ask you for. Now in this case I can't ask you for the term x to the power of 3 because there won't be one. Because the fact that it's already x to the power of 2, so our terms will be, so the first one would be 3, 0, and it would be 4x squared to the power of 3. Okay. The next term would be 3, 1, and it would be 4x squared to the power of 2 multiplied by 1 over 2y to the power of 1. Okay, and so on. So if I were to ask you to find, right, let me change this question to give you one that you would do. So what if I were to ask you, so we've got 4x squared, what did I say, minus, so plus 1 over 2y, and if I made it to the power of 7, no, I won't do that. I'll do it to the power of 6. If I said to you, I want to find the term in x to the power of 6, that's the term I want. How would I go about doing it? Okay, so I would start with going 4x squared. Well, that needs to give me an x to the power of 6. So the way to do that is to cube it. Okay? Because if I expand that bit, I will get 4 cubed x to the power of 6, which is what I want. Now I just need to figure out the other parts. So it will be multiplied by 1 over 2y to the power of 3. How do I know that bit? Because this power and this power have to add up to that power. What will be in the front? 6 and 3. Okay.
I mean, I get it, but it's still like.
I get it, but I would never even do it.
Yeah, you will. You'll be able to do it.
No.
Bit of practice, you'll be fine. So let's just do bit by bit then. So we've got the 4 cubed. Well, that's 64x to the power of 6 again. So that's that bit done. What's the 6-3 bit? Let's just do that next. $20?
Yeah.
Okay, so times 20. And then what's this bit at the end? So that's that bit done, and then what's this bit? So we've got to apply the cube there, so that's still 1. And then we've got 2y cubed is 8y cubed. Okay? So now we just have to simplify as much as we can. So when we multiply by a 1 over, are you happy if I do it's 20 times 64 times x to the power of 6 all over 8 times y to the power of 3? You okay with me doing that? Yeah?
What else would you do?
Well, now I need to, the reason why I did that is because what I can do is simplify now. So the 8, that becomes an 8 and that's a 1. So now all I have to do is 20 times 8, which is, you can do that straight away.
160.
Yeah. X to the power of 6 over y to the power of 3.
Oh, so complicated.
So much work.
There will be lots of work in these things, but not hard work, just lots of parts. So you need to keep it organised and not try and do too much in your head in one go. You need to write it down. These questions will produce a lot of writing.
Because that's how you make dumb mistakes.
Exactly. Yeah. Trying to do it in your head, you will need to write it down. Okay. Would you like me to recap on any of that? Is there anyone? Or are you good with that? Think you're good with that? This would be one of the harder ones of this. Okay? Would be
Really?
one of the harder ones.
28.
Of just a single term. So the hard bit is when I say to you, find a constant term for it. So for instance, in this one, will there ever be a constant term?
Yeah. No. Yeah. No.
Because there's a y and an x in both of them, there's not.
Exactly. So you're always going to end up with an x or a y in the term. There won't be a constant term.
I have a question.
Yes, what's your question?
When you're doing like the 4x squared close bracket cube, and then the 1 over 2y close bracket cube,
Yeah.
could you do like 4 and 2 as the exponents? Because those add up to 6.
Yeah, you can. So up here, you mean it could have been 4 and 2?
Yeah.
Yeah, but that wouldn't have given you the right x. That's all. It could be 4 and 2.
So it has to add up to.
Yeah, because that's what I asked you for, the term in x to the power of 6. So if I said to you, now, actually I want the next, a different term, it would be x to the power of, well, could it be 7?
No.
No. So one that I could ask you for is x to the power of 8. Or I could ask you for a term in y to the power of anything, yeah? If I went for the y, I could say, give me y to the power of 7 and find that term.
Wait,
But that would be easy, no? I would just make that 7. That's easier.
when you, like, you know, you said one of the harder ones would be if you're trying to find the constant. For that, do you have to write out the entire thing?
No.
Oh, so there is a constant.
I'll just start it now. We're not going to have any time to do it. One where they like to say, so if it was 2x squared plus 1 over x to the power of 8 or something, okay? They would ask you for the constant term in that. And basically what happens is you end up with a 2x squared to the power of n minus r multiplied by 1 over x to the power of r, and you need that with that to be the same as that and that, so that the division cancels the x's out and you end up with no x's. Alright? But that we'll talk about when you're a bit more used to doing everything else. Okay? But that's the next stage. Alright? Great.